Hello everyone! Welcome once again to Small Terrible Channel. This is Mr. Aseno, your teacher for today. So this is still graded science, unit 1, force, motion, and energy. Okay. How was our last session? Did you learn a lot? Okay. So in this session 2, we are going to discuss the topic balanced and unbalanced forces and Newton's first law of motion. This is still in chapter 1, entitled Forces and Motion, under unit 1, force, motion, and energy. Okay, this is a pretty exciting topic. Okay. Still physics 101. Now, we're still in week 1, quarter 1, week 1, learning competency. We have investigate the relationship between the amount of force applied and the mass of the object to the amount of change in its object's motion. That is still our competency. Now, in this session 2, okay, these are the learning objectives. First, differentiate between balanced and unbalanced forces. Second, explain Newton's first law of motion. And of course, cite examples of situation demonstrating Newton's first law of motion. Let's get ready. You still remember this picture in our last session? So what is being shown in the picture? Okay, still, it is showing force, right? So do you still remember our common sense definition of force? Right, you're right. So our common sense definition of force or idea is force is that it is a push or a pull. Now, let's take a look some situation, okay, when forces and what type of forces are present, okay? All right, ready? So here, what happens when forces are unbalanced? Guess what happens? There you go. That's what happens if forces are unbalanced. Did you see that? Building collapses onto the ground. That's what happens when forces are unbalanced. Now, what happens when forces are balanced? Okay, let's take a look at this. Oh, isn't that amazing? Can you do that? So that's what happens when forces acting on objects are balanced. Okay? So balanced and unbalanced forces are pretty much exciting topic. Now, forces can be balanced or unbalanced. So let's define first a balanced force. A balanced force is a force in which the net force equals 0 and there is no motion. Let's take a look at this example. These are people playing tug of war. So we have 3 Newton of force, this group of people on the right side. They pull the rope going to the right with the magnitude of 300 newtons. With the opposing force, another 300 newton going to the opposite direction, and this time to the left. So what happens? 300 newton of force opposing, that is minus 300 newton of force, equals on a balanced force with no motion. So they will stand still. There is no movement. The forces will cancel out. 300 newton force going to the right, 300 newton force going to the left. So there is no motion. So a balanced force causes no motion in this example. All right, now let's take a look at unbalanced force. An unbalanced force is a force in which the net force is greater than 0, okay, causing motion. Okay, let's have a 400 newtons of force exerted by team A going to the left, opposing, that is minus 300, another 300 newtons of force going to the right, exerted by team B, that is equal to the net force of 100 newtons. So an unbalanced force with motion. Okay, that means team A will be able to pull team B. So the direction of the force should be going to the left because 400 Newton is exerted by this team A compared to the lesser force exerted by team B, which is 300 Newtons. So again, these two pictures represent a balanced force and an unbalanced force. Okay, do you understand? All right, good. Now let's take a look at the summary. Balance and unbalanced forces. Let's take a graphic representation, compare and contrast. Okay. So balanced and unbalanced forces are pair of forces created by a push or a pull. Okay. Now let's take a look at unbalanced forces. Unbalanced forces when it comes to magnitude that is not equal in size. Okay, the size or the magnitude is not equal. That means it always causes change in motion. So when there's unbalanced force, it always causes change in motion. Not any motion, but it's change in motion. Direction can be opposite or same direction. Okay? Now, let's take a look at balanced forces. So when it comes to magnitude, it's equal in size. Balanced force is equal in size, unbalanced force not equal in size. When it comes to direction, the direction of the balanced forces, it should be opposite in direction. Okay, and then while in the unbalanced forces, it could be opposite or the same direction. When it comes, there is no change in motion. There is no change in motion. So this is a summary of balanced and unbalanced force. Okay, let's take a look at this example. Are the forces balanced or unbalanced? Let's have a situation, letter A situation. A car sitting at rest on the road. You have there two forces acting on the car sitting at rest on the road. You have the normal contact force going up. Another force is the gravitational force exerted by the Earth. Okay. You have two forces, opposite, equal in magnitude, and opposite in direction. This is our free body diagram. Okay. Observe. So the magnitude is the size of the force is the same based on the length of the arrow and in opposite direction. What do you think is this kind of force? Balanced or unbalanced? Perfect. It should be balanced force. Now, another example. Let's have it. Are the forces balanced or unbalanced? A car moving at a constant velocity along the highway. This time around, the car is moving at a constant velocity along the highway. You have different forces acting on the car. So this is our free body diagram here. We have their forces. What do you think is the kind of force existing in this situation? Balanced or unbalanced? Okay, of course, it is balanced. As you can see, the different forces, normal force and gravitational force still same in magnitude as represented by the length of the arrow. And the frictional force and the applied force is the same. So because although it is moving, it is still balanced because according to the statement, it is constant velocity. It is constant velocity. Okay, remember? So then don't get confused. Even if it is moving, it doesn't mean the forces should be at balance because it is moving. No. As long as there is a constant velocity, there's no change, there is no acceleration, it is still balanced forces as represented by the free body diagram. The forces are equal in magnitude. Okay, do you understand? Good. Now, our situation. Let us see situation. A car accelerating to the right along the highway. What do you think is the force? Balance or unbalanced? Okay, based on the statement, it is accelerating to the right. As you can see, the four forces acting, especially the applied force versus the frictional force, you see that the frictional force is lesser or shorter compared to the applied force. So you can see by the diagram itself, you can see that the force acting is unbalanced because it is accelerating to the right. It is not, the velocity is not constant. Okay. Let's have letter D. Okay, let's try this. A car coasting to a stop that is to the right along the highway. What do you think is the force? Balance or unbalance? Force? Yes. Based on our free body diagram, you can see there is one force, the frictional force. Okay, because remember, the car is moving and suddenly it goes to stop. Okay, so there is an unbalanced force applied, or else the car will not stop. So the car stops as it moves. It stops because there is an unbalanced force applied. Okay, so what causes the car which is moving to stop? It is the unbalanced force. If there is no unbalanced force, it will continue to move. Therefore, this situation, the force involved is unbalanced. How about this one? Okay, a pail hanging from a rope is held motionless in a well. Okay, it's hanging on the rope. There's a tension force, but it's motionless. It's not moving. And based on our free body diagram, you can see the length of the arrow is still the same. Are the same, so meaning it is a balanced force. About this one, a pail hanging from a rope is lifted at a constant speed. This time around, it's moving, lifted up, but at a constant speed. Still, the force involved is balance, because remember the term constant speed, though it's moving, but the speed is constant. That is why in our free body diagram, the tension force versus the gravitational force is equal in length. Okay, excuse me. Okay, let us see. A pail hanging from a rope is lifted with an upward acceleration. Look at the word upward acceleration. So, of course, the force uh, found or exerting of the object should be unbalanced. Since, as you can see in the free body diagram, the tension force is higher compared to the gravitational force because it is accelerating upward. The velocity is not constant, it is accelerating upward. Okay, so balance forces. Okay, these are the main concepts. The net force acting on an object sums up to how much? That is zero. The net force acting on an object sums up to zero. Call that balance force. Another key term, key idea. It does not produce acceleration. So a balanced force does not produce acceleration. Third, there is no change in the motion of an object. The motion, the velocity is constant. A body at rest remains at rest. Lastly, a body moving with constant velocity will maintain its constant velocity. So those are the key concepts talking about balanced forces. Okay, there we go. Did you get it? Good. Now let's talk about unbalanced force. Let's try to summarize the key concept. When it comes to unbalanced forces, the net force acting on an object is not equal to zero. Remember the key terms, not equal to zero. And it produces acceleration. There is an acceleration, change in velocity. Causes a change in motion, in speeding up or in slowing down. When there is change in motion, either speeding up or slowing down, then the forces involved are unbalanced forces. Okay. Now, are you familiar with this man? Of course you are familiar. Okay. Of course, he is Sir Isaac Newton. He is considered as the father of classical physics. Let's talk. Remember, Isaac Newton formulated the three laws of motion. So let's talk about his first law, or the Newton's first law of motion. So the Newton's first law of motion states that an object that is at rest will remain at rest, or an object that is moving will continue to move with constant velocity if and only if the net force acting on the object is zero. So if the force is acting on it is balanced or zero. Okay. So in mathematical term, we can say that summation of forces is equal to mass times acceleration vector. That's the mathematical term. So when the summation or net force or summation of forces is zero, that means forces cancel. So meaning no change in motion. The motion is zero or there is no change in motion. This is the mathematical term of the Newton's first law of motion. Okay. Let's dig deeper. Okay. Let's watch a video. Okay. So what is the Newton's first law of motion? Okay. Of course, we stated that above. But let's take a look at this video. Okay. All right. This man is trying to push a boulder, big rock. Okay. And according to the Newton's first law of motion, an object will continue to remain at rest or in uniform motion. So let's focus on this man. Trying to object the boulder or the big rock is at rest and he's at rest. It's not moving. And the other side, this boy is playing the ball, the soccer ball. Okay, the boy kicks the ball and it is object in motion. When he kicks the ball, the object is moving. Okay. And according to the Newton's first law of motion, it will continue to move forever in a straight line. Do you agree that it will continue to move forever? Well, maybe you agree. But in our daily experience, it does not happen that way. It will not move forever. Why? Because there are external forces which are unbalanced that will make this moving ball stops at a time or at some times. I'm sorry for that. Get back. Okay, now the ball is moving. But it will continue moving forever based on the Newton's first law of motion, supposedly. Okay, there. But did it move forever? No, because there is an external force which make it stop. And now on this side, the boulder that is stationary when pushed by the man, the boulder moves or the big rock moves because there is an unbalanced force exerted by the man. Okay, so that is the basic demonstration of Newton's first law of motion. All right. Okay, let's continue. All right. So here's our illustrations which will help us understand about the Newton's first law of motion. What you see in the illustration, you have here a boy, kid, riding in a cart and then connected to the dog. So a body, according to his idea, a body at rest tends to stay at rest. That is why when the dog moves, because the dog sees the cat, the boy fell down and remained where it remains. And the cart moves, but the boy remains. So he fell down. Okay? So a body at rest tends to stay at rest. That is a very concrete example of the Newton's first law of motion. Sorry. Okay, let's have second illustration. We have keep on tracking. A body in motion tends to what? Stay in motion. That's a very good idea. Okay, it stays in motion. So this caricature sums up the idea of the Newton's first law of motion. For the Newton's first law of motion, inertia, the idea of inertia cannot be separated. What happens to the man riding his nice Ferrari, a top-down car? So when the car bumps to the wall, what happened? Because according to the Newton's first law of motion, a body in motion will continue in motion unless acted by an external unbalanced force. That is why. That's what happened to us or to the man. That's what happened to the man. It continues to move He continues to move rather after the car bumps into the wall. That's a very good demonstration of the Newton's first law of motion. What concept is involved? Inertia. What is that inertia? Let's talk about inertia. Inertia, every object has inertia. Do you agree? A property that resists acceleration. So when we talk about inertia, it is a property that resists acceleration. The amount of inertia an object has depends on its mass, which is roughly the amount of material present in the object. So mass is a measure of the inertia of an object. So let's take a look at this example. Which has greater inertia, the elephant or the man? So elephants has more inertia than human, which means it's harder to change an elephant's motion than a human's motion. Do you agree? Of course, the elephant is very massive. It has greater mass, therefore it has greater inertia. Since inertia can be measured depends on mass, and mass is a measure of the inertia of an object. It is hard to push or to move this elephant compared to this man. Okay, so it has an inertia. That is a property that resists acceleration. Okay. Now for a group activity, teachers, you can apply this in your class if you are doing this in classroom settings. You can do this group activity. But if students stays at home, you can do this individually activities. So that's very easy. All you need to do is practice. You have to prepare at least 4 cups with same in sizes, and then a cardboard will do. Okay. So pretty sure as long as you practice, you can do that. Okay? Now these are our questions, or shall we say processing question. What enabled your group to successfully carry out the given task? Okay? What problems did your group encountered while carrying out the task? How can this be addressed when applied to real scenario? So those are our processing questions. Can you still think of another activities or situation that exhibits Newton's first law of motion? Okay, please share your suggestions to the class. So summing it up, let's sum up. Forces cause changes in motion. Remember, forces cause changes in motion. Newton's first law states that every object continues in a state of rest or of uniform speed in a straight line unless acted on by a non-zero net force. Okay. So let's check concept check. Let's check how much you understand. First question: which of the following statement is most correct? What do you think? Okay, of course. What's your answer? Okay. Answer is letter D. Both A and B are correct. It is impossible. Letter A. It is possible to have forces on an object in the absence of changes in motion of the object. It is possible. B, we have it is possible to have forces on an object in the absence of motion of the object. Those are the statements which are most correct. Second, explanation. Choice A is true. Newton's first law tells us that motion requires no force. An object in motion continues to move at constant velocity in the absence of external forces. That is true. Okay. When you throw a stone in the outer space, it will continue to move forever as long as there is no external force acting on it. Here on Earth, we cannot see that because we have presence of gravity. But when you throw a stone in the outer space, definitely it will continue to move forever as long as there is no external force that will act on it. Choice B is also true. A stationary object can have several forces acting on it. But if the vector sum of all these external forces is zero, there is no net force and the object remains stationary. Okay, excuse me. So next question. An object experiences no acceleration. Which of the following cannot be true for the object? A, a single force acts on the object. B, no forces act on the object. C, forces act on the object, but the force forces interact. What do you think? Okay, answer should be letter A. A single force acts on the object. Which of the following cannot be true for the object, as the object experiences no acceleration? Explanation. If there is a single unbalanced force acting on an object, the object will experience a net force and therefore will accelerate. An object will only experience zero acceleration if the sum of the forces acting on it equals zero. Okay. That's a very good explanation there. So these are our references. So thank you very much for your assignment. So your research on Newton's second and third law of motion. Right. So thank you. See you in the next topic. Have a great day. Thank you for listening.